Hi everyone, welcome back for another video. In this video I will be deriving the series expansion for cosine x. So starting off with the general form for the series expansion, for some function f of x, initially we have the function evaluated at 0 plus its derivative evaluated at 0 times x plus its second derivative evaluated at 0 times x squared, third derivative evaluated at 0 x cubed, and so on. I like to think about the pattern as this, taking each derivative and when it's evaluated and just doing it as a sub 0. And then trying to solve for those coefficients. So if our function f of x is cosine of x, just plugging that in, we have this. Getting our first term, a sub 0, we can solve for it when we're evaluating cosine of x at 0. And we have a sub 0 equals 1. Taking the derivative so that we can determine the a sub 1 term, we have negative sine of x equals all of that. Evaluating it at x equals 0, we have a sub 1 equals 0. Taking the derivative again to get our a sub 2 term, we have negative cosine x equals 2, a sub 2 plus 3 times 2 a sub 3x plus 4 times 3 a sub 4x squared, and so on. Determining that a sub 2 equals negative 1 divided by 2 factorial. Then taking the derivative again to figure out the a sub 3 term, since it's another sine of x, evaluating it at 0 will result in that coefficient being 0 as well. Determining what a sub 4 equals, taking the derivative again, we get cosine x, so this is going to be a non-zero term. A sub 4 equals 1 over 4 factorial. As we can see a pattern starting to emerge, that the coefficients alternate between being 0 and some value because the function we're evaluating is either cosine or sine. At 0, cosine is all these. It's going to be 1, and sine is 0. So then we can see that the sign changes as well, because every time we take two derivatives, we're going to get the same function back, but negative. If we're taking the derivative of cosine, we get negative sine. And then plugging in those coefficients, we have cosine of x equals 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus so on. So let's graph these three terms in cosine of x and see how close this approximation is. I'm using Desmos here, and as you can see, it's a pretty good approximation of cosine x when the x is between about negative 2 and 2. So we can see if we get more terms, the approximation is going to get better and better and better. And when cosine of x, when x is really small, cosine is 1, as you can see. Thank you. See you in the next video.